pieces of software, such as the one I'll be talking about today. My usual disclaimer is, this is the survivorship bias. Only if stuff works for me or for us, it doesn't mean it generally holds true. It might be just a misinterpretation on my behalf. So you adapt, you critically ask yourself, is this true? Does this work for me? And adapt what you want. Disclaimer 2, this thing called AI, and that's literally what comes up excuse me, when you search for AI on Wikipedia. As mentioned previously, I find the term intelligence for the current state, especially of these techniques we're going to be talking about, a bit misleading, as they don't really fulfill my idea of definition of intelligence. I think it's more apt to look at them what they are, a really advanced generative technique. I saw this when I flew in Munich Airport. AI has gone mainstream, and I'm a bit dumbstruck by this. Not by the fact that the local low-budget advertising company is the first one to embrace an automated image generator, but that given the massive opportunities to create enchanting, wonderful worlds, sit in front of your screen and you type cat. So let's talk business motivation for this talk. It's twofold. We've seen lots of discussion, let's call it that, around the arrival of these image generators. Some people fear for their income. Some people see it like a savior. I think it's neither. I tried to give you an idea where I think we're going with this industry when it comes to AI and those image generators. And I think there's going to be two ends of the spectrum which will be important. One is the very social, very conceptual skill that you need in order to be able to drive these machines with prompts or with any input, most digital language, to generate concepts that sit well above this. And I think that will be the point that will set your creation apart, as was always the case. And we're finally at this point where technically we're as far where we can go with the adage that everything that matters is the concept. So that's the one end. The other end is the end where you explore the technique and the creation process of the image itself, the technology of it, and modify it, mingle with it to create something new. So very tech aspect. So I think those is the outlook for the most successful or most safe positions that you have in the immediate future, either strong conceptual and vectorization skills or extremely strong tech skills. And that's been coming for a few years now. So we've seen in the previous talk, we talked about mainly prompting, so cat, dog, spaceship, whatever. And prompting is cool. But as mentioned, prompting requires you to be good at language, to be good at semantics, and to maybe learn the semantics that a certain model requires you to output what you want. You can see this. There was Stable Diffusion 1.5, which is what everyone basically used to get their ugly avatars. And then there came Stable Diffusion 2.1, and it went totally nuts with the same prompts. You have to learn a new way of prompting, you have to learn a new way of controlling it. So prompting is cool, but it's dependent on the model, and also it's dependent on your abilities to use language. We have examples in the audience that are very good at this. We have examples on the stage who are very bad at this. So especially for visual people like me and you, designers, it would be nice to be able to control Stable Diffusion. And again, I was riffing on people being only creative to type cat, and of course, the most sensible thing I could come up with was spaceship. Excuse the ugly visuals, but we're going to bear with it for this talk. How will we be able to tell Stable Diffusion not only in which style to generate the spaceship, but also the form, the shape of it, where it sits in the image? Well, traditionally, your workflow or your model goes like this, really oversimplified block diagram. You enter a prompt into, in this case, Stable Diffusion 1.5, because that's what the method has been trained on. In this case, a spaceship in the style of John Berkey, high detail, cinematic UHD, and this is like the lingo you're going to be using when using Stable Diffusion 1.5. You add Octane, you add ArtStation. You have your specific dialect when talking to the machine. And it generates this thing. And superficially, it's super fine. I mean, it is a spaceship-ish thing in the style of John Berkey. Just maybe it's not in the center. Just maybe it doesn't have the shape that I want. Just maybe I want to get rid of that kitschy planet in the background. So can I find a way of augmenting this prompt? In this case, with a depth map that I could render out of 3D software, or could I generate out of an image with that prompt in order to get a stylistically similar image? And you could even argue that the palette is roughly similar in areas, but to drive the shape of the whole thing, the appearance. And we can do that. We just have to add this conditioning info. So a conditioning is telling a model, please generate something in the shape of this or with this verb. So in addition to adding the conditioning of a sentence, we also have to train another network, in this case called ControlNet, to be able to interpret our conditioning here and feed it into Stable Diffusion to finally come up with what we wanted, a combination of text and image. And for that, we have to fumble a bit around with our unit. Again, these are the blocks that take our image, the broken telephone line analogy, hand it over to the next step, meanwhile compress the information, and on the other side of this, on the right side of the unit, try to make sense out of that information and come up with an image again. Mostly driven by the prompt we entered. So that's the data flow I just described, but also, as Chris mentioned before, we have what's called skip connections to preserve detail in our image. We can reorder this, so that is the shape that you find in literature, and it's got a U-shape, that's why it's called UNet. You can reorder this to sit linearly and draw the skip connections here. It's exactly the same architecture, exactly the same network. What I can do now is take this, and again, this works as before. Spaceship style John Berkey, generate some spaceship. But what this paper does, and they advertise it cleverly, because they advertise it with, it makes your training fast, and also is highly controllable. And if you're into papers, this is a good paper to read. It's very simply written. It's got 25 pages or so, out of which 6 are text, and the rest is just images. It's just image over image. So it's this. It's a very colorful paper, and it's very easy to read. So if you're into that, highly recommend. What they do is they take a copy of the network that we have. And again, the network that we have is Stable Diffusion 1.5. And we take a copy, but we only take the first half of our unit. The advantage here is that we copy all the training that's happened, all these 5 billion images that Stable Diffusion 1.5 has been trained on, cost a lot of money, cost a lot of time. We take that training and we preserve that in the complete UNet down there. We freeze that, so we cannot train the UNet down there. But what we can train is the unit up there, and we can train it on 2 conditions: the prompt, the text that we feed in, and this image. And we compare this image with what it generates out there, calculate the error, as Chris mentioned, and then try tweaking our parameters in there to make it generate what we want, more or less. After this training is done, and again, this training can happen really fast meaning 10,000 to 100,000 training steps, which is even doable on a normal desktop computer with admittedly a hefty graphics card, but at least you don't have to have a computer cluster. After we train this network, we take those skip connections from the previous network and feed it only in the encoder half of our UNet. And we just add this to the info in our skip connection that's already there. And by this adding the info that we extracted in this network, that we learned from this network, and add it to all the semantics that we already learned in Stable Diffusion 1.5. So we know the shape and a bit of the content from the ControlNet up there, and we know the prompt with the whole semantics from the ControlNet down there, from the network down there. The literature is not really strict on what they call ControlNet. Also, the users are not. So sometimes people just call this additional network, the half-network ControlNet. The literature calls the combination of the ControlNet and the Stable Diffusion a ControlNet. Sometimes the whole training procedure is called ControlNet, so it's a bit messed up. But what you can do is now have this ControlNet generate that. Not only that, but you can also combine ControlNets that have been trained on other contents. For example, normals, or I will get into what else has been trained, to further drive the creation of these artworks. Not always does this give you a better result. Sometimes it just gives you longer calculation times without the benefit of seeing much more change or much quality increase in the output. But it's there, and you can combine it. You can combine 4 or 6 networks with the technique I want to show you. Of course, the guys who invented this also trained a few models. That means they not only prepared a model, in this case for depth and for normal map, but their first and foremost model that they trained is one that works on canny edges, which is quite useful. Canny edges, in this case of a cat, are these weird edges. So it's an old school edge detection algorithm, which is there in most of your photo editing software, such as GIMP, Photoshop, Krita. It just finds edges. The good thing about it, this edge finding is really fast. It's super easy to implement, and you can do it in any software. And also, there is what's called a preprocessor, so a step in the pipeline that can automatically extract those edges from a photo. So basically what it enables you is,
put in a photo, will automatically extract the edges, and then, with this, generate an image. In this case, of course, of a cat. Native speakers. How do I pronounce this? How do I pronounce his name? Is it How? Is it Huff? Seriously, that's an honest question. Native speakers. And English, you're natives. Hugh? Let's go with Hugh. Hugh lines. Thank you. Hugh lines, another edge-finding algorithm, comes from physics, was used in a bubble chamber used for particle physics, so they wanted to find particle trails. Really good at finding straight edges in an image. In this case, of course, for architecture, it lends itself to that. Then we've got HED boundary maps. HED is short for holistically nested edge detection. This is a kind of more meaningful way to find edges. So we are not crowding our images with tiny edges, but try to find the broad outlines. And that's done in a convolutional neural net. So the same thing that in the browser demo you saw generates those edges. Fine, you say. What if I want to input something myself? It's also been trained on quote-unquote human scribbles. What do I mean by human scribbles? The issue is always finding a data set. So you have to have lots and lots of data, in this case either our edges or our depth maps, with matching images. So you could get a lot of students or a lot of really cheap labor to manually sketch out over an image. But what in reality you want to do is, and what they did, is they generated the input data procedurally. So they took these HED lines, they adjusted the contrast, and randomly deleted lines out of there and wiggled them and deformed them. They basically took this and messed it up, and that's for them is a human scribble, and it works really well. Further, we have OpenPivPuff, which is a really weird skeletal model. I like to point out the way the face here is represented. And we also have OpenPose, which is a bit less scary and works the same. Then we do have segmentation, so you can feed in an image, a colored image, and tell it where the sidewalk should be, where the street should be, where buildings should be, where the sky should be, etc., etc. Again, these segmentations usually are created using a neural net from an image. We have normals, which you've already seen, and these normals, interestingly, are generated out of depth maps, which it also supports. And depth maps in this case were extracted using an algorithm called METAS, which comes from automotive, where you want to take a camera that's on your dashboard and have your self-driving car ideally use that image to estimate depth of the other cars or of pedestrians. But there's more. Also in this paper, they provide features for masking, so you can take an existing image, mask out something over it, and add, in this case, I think scribbles or hue lines, and generate and infill this image with a newly generated horse. So just a brief comparison of the input types. Again, this thing I think has as a prompt robotics in combination with professional nice image or something like that. They have a standard prompt. And your canny edges generate this robot, you depth map this one. The HED and normal also quite what you'd expect. The hue lines a bit different in this case because I think they did not get every line that was in the original image fed in there. So the robot looks quite a bit different, but also the scribbles are quite similar. As for the training speed, here's an example. So usually you have to train your network drastically low, so weeks. In this case, as we take info from the pre-existing Stable Diffusion 1 info, we can spare some training steps. And you see, yes, the 1,000 training steps, not really there, but it starts from 10,000 training steps that we are starting to see a lion looking lionish. So it's really faster, and this is the input image that was used to generate those canny edges. That's the theory. Questions, remarks, angry comments so far? Good. We're going to talk about how you're going to use this. Let me just duplicate my screen. Brilliant. So, the original way we're going to use this is not as Chris used this, where he really literally programmed the whole network in Python. We're going to use the work of some open source developers, and this, who knows this? Show of hands. Okay, well, that's good. For those who don't know it, web UI interface for using Stable Diffusion. Again, you just give it a prompt here, cat with hat. Press enter and pray that everything is still working. Yeah, and it generates a hat with a cat with a hat. So, and what we can do, and what I want to do to implement this whole thing in Houdini, is interface into this here, because it makes it so much easier. I don't have to build my own networks. I can just tell it, please do this, please generate this. Let me just see. And let's get back to here. So how do you get that into Houdini? Again, block diagram. You've got Houdini and you've got WebUI. And you want to communicate this. You want to tell it to generate something. In our case, let's start out with a simple prompt. And for that, we're going to use a really brief Python script in Houdini, just in a Python node. In this case, handing over what's called an API call. An API, application programmer's interface. It's basically like a command line for the program. You tell it, please generate an image using prompt XYZ with this sampler at this resolution. Then WebUI thinks and passes back this data, an image plus the metadata, repeating your prompt and the seed and everything back to Houdini. So to extract this image, we have to solve an issue because our image is passed as this. This is ugly because this is the whole image as a bytecode. So it's just your bytes typed out as a string. What do? Hint for everyone who's programming Python in Houdini or Python in general. ChatGPT to the rescue. It's good at it. These are the questions it excels at. It sucks at any wider Stable Diffusion questions. How do I XYZ in Stable Diffusion? Because it pretends it doesn't know it because it wasn't there in its original training data. But the standard kind of Python programmer questions, it's really good at that. So after we extracted our image, with the help of ChatGPT, we have an issue. Because what we'd like to do, ideally, is have this in Houdini's 2D compositing background. The problem with that is it sucks. It's easy, it's super difficult to use, it's super difficult to script for it. So instead, what I opted to do is split this into its 3 RGB channels and store those out as 2-dimensional volumes. 2-dimensional volumes are just images. It's just like individual tiles, your pixels. And then merge those together in Houdini's compositing environment, which is quite easy, and then finally save this out. So that's the whole tree, just for a single prompt. Somewhat clear. Somewhat unclear. Any questions about this? Any major questions about this? Okay, because now we're going to take this and add to this as a condition an image which we pass. And for this image, what I'd ideally like is to be, let's not say real-time, but in an interactive way to be generated. And again, I could be clever about this. I could write a shader, I could hook into Houdini's rendering engine, but I'm lazy and stupid. So I wrote my own little rendering engine, which does this. So you've got your camera, and the center of the camera is the black dot here, and you have your object, in this case, this sphere. So now to render this, what we need to do is place a grid, which has the shape of our image, square, 512 by 512, in front or in the back of the camera. I'll get to that. And then through each pixel, originating from the origin of the camera, through each pixel, shoot out a ray into the scene. And check which rays hit some geometry, and then it's easy for me to just geometrically calculate, for example, in this case, the distance from camera center to the geometry, and thus get a depth map, or ask Houdini whether the surface normal in this direction shows, or which color the surface has. Now, why would I put the grid in front of my camera? I could as well put it in the back of the camera. It just makes calculation a few things a bit easier. And actually, I must give credit to this whole setup, because I was even too lazy to build this, so Chris did it, so thank you, Chris. And this is able to interactively spit out a bunch of passes, a cheap lighting pass up there, your depth, your normal, and a segmentation pass. So each primitive, each connected polygon has a different color. And now what I want to do is take Houdini and first prompt WebUI to just generate a spaceship in the style of John Berkey. And then take this input image that you see, the intermediate image, together with this normal that we generated, and feed both together with the prompt into WebUI. So we generate this image, which is really close, again, in color and arguably a bit in composition to the intermediate image, but which is driven by my Houdini geo. And I can do that with all sorts of info. Again, I could combine up to 6 nets. All right, Houdini time. Let's look at this in Houdini. Cool. Let's see how the Houdini UI looks. Okay. And again, apologies for the fucking ugly artwork. That's what it generates. Let's just click through this quickly. So we've got our ugly-ass spaceship here. And what it does now is cooking a bit. So Yeah, that's our ugly ass spaceship, really couldn't be ours. And then we feed this into our rendering engine, which does exactly what I told you, takes an input grid, transforms it into points and in front of our camera, like this. So when I look through my camera here, you can now see the grid is smack in front of the camera. And then, with the help of a few lines of vex, we are shooting out rays from our camera through each point here, and then calculating the depth from it, the normal. What else do I have? Color and a mask, I think, and that's what I get out and write into those volumes. Let's have a look at them. In our composite view, that's still the old thing that I still have in there. We've got normals, we've got a color, which is really ugly, we've got segmentation and a mask. In this case, the whole image is masked, as this was a previous example, and it had a cyclone. So that's what I'm feeding now into the second part of my setup, which is the actual ControlNet stuff. And I've got multiple examples in here. So I'm bringing in these layers that I rendered out. And then the first thing, what I did is just your normal text to image with the ControlNet. In this case, let me just scroll through what I have there. It's just your text to image. It's just a standard normal thing. So let's have a look at what this thing generated. Again, I think my prompt in this case was spaceship, style of John Berkey. And let's have a look at the color. And that is exactly what it generated. So again, I tied the seed, that means the initial noise that I feed in my image, to my frames down here, so I can skip through different generations that it does with the same prompt. And it's this, what I, in this case here, take and feed it into our ControlNet. In this case, I am taking this blobbish thing together with, let me see, this input image, where I think space sculpture, prompted for space sculpture. So I'm taking this plus this as an input for the ControlNet, together with the prompt, an abstract space sculpture, and finally I arrive at this. So it's these weird kinds of sculptures. And those were driven not only by the normal map, but also by the depth map. And in this case, as the network doesn't really know how to interpret these shapes, how to interpret these normals, we get those messed up errors. So that's worth experimenting with your different networks, with your different control nets there. So switching out depth with normal, or maybe in this case, even a canny, a simple edge detection. And that's the gist of it. I'll just show you that this is by no means interactive. Many of the plugins or of the demos that you see out there give you the illusion that what they're doing is interactive. It is not, because what you have to do is, in the background, is call the ControlNet. In this case, the first thing it does, it loads up the ControlNet. Again, in this case, the segmentation ControlNet, which you can see here. It says ControlNet Stable Diffusion 1.5 segmentation. So now it's still loading. Just going to wait for that. So now it's got that. Now it's going to load the ControlNet for depth. Again, combining multiple control nets might not make your image generation faster, quite the contrary. And after we've been through this, after ages, and you see that working with AI is weirdly similar to standard 3D CG, it starts generating and starts sampling. And these control nets will be cached the first time after they load it. So you can skip that, but you won't be able to skip the sampling part here. So it'll take a while to arrive at this image. So once you move your camera around, don't expect your update to be immediate. You will, let's go through another image here. You will have to wait until this thing has done its samples. Granted, I could slow this down to 4 samples, 8 samples, but then again, my image would look a bit more wonky than I'd like it to. But that is the very coarse, very duct tape way of how I get Stable Diffusion into Houdini and how I work with it. Questions? Yeah? Yeah. 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 Okay. So just so the question is, how did I get those normals and the depth map and everything? And you assumed that I generated this 3D representation out of the normals, right? Yeah, I didn't. So this is the input data. So I'm converting this into a depth map into a normal map. That's why I built this cheap rendering engine. So I'm taking this 3D modeled image as an input. I'm rendering out my depth map, and that is an input for my ControlNet. So that's the way around, and not from the normal to the geometry. I cannot quote on that. I cannot comment on that. So the question was, is that whole duct taping and performance thingy going to be solved in the future? And I cannot comment on that. How do I see this inside a creative process? Okay. There are multiple ways of viewing this. The most obvious would be concepting and ideation. I think when you've worked with clients at a certain level, the expectations that they have can be quite hard on you as a designer, as a craftsman, where deadlines are brutal sometimes. So we've had clients who asked 30 new style frames within 16 hours on a certain quality level. I think that will be doable. And in a very cynical view, you could say that even finally we outsource this to marketing, who don't know what they want and how to formulate this, and make up their mind first maybe, and hand the visual concept on. But again, that might be naive. You could see it as a very naive version of a filter. I'm not sure if any one of you has witnessed the discussion about the recent Carter Digital video, where they basically took real-life shot footage and turned it into an anime. But also that involved quite a lot of manual or semi-automatic labor in post. You could also use it to generate textures. So I could take this image and reproject it into the scene. I think that's an absolute obvious example. But I think we'll progress faster. So we can now see the first good data sets for 3D that are tagged and caption derived. And you see the first good diffusion models that arrive for 3D. So with a prompt, you can generate a 3D model instead of an image. It is difficult to predict. Again, I think as long as you are able on a technological or conceptual level to crank out work that stands on its own and doesn't go under in the sea of mediocrity that we'll see, you're going to be safe-ish. If you relied on being an executor for something, for a concept, I might get worried. I mean, yeah, so your point was if you have a robot, the robot is going to take your place. Yes and no. I mean, we are now witnessing in a white-collar job for the first time what fears have gone around in blue-collar jobs for a long time. And also there, the hell of representing everyone with a machine that can do their job X times better hasn't arrived. The job skills have just progressed to people who want to be employed to have a certain skill level, or be willing to do the grunt work that a machine is not capable of doing yet. Again, the optimistic and very cynic way of viewing at it. And of course, there's a whole array of grayscales between it. It's not that black and white, but I'm not extremely panicked yet. Does that answer your question in a way?
There's an answer.
Yeah, I think there's no set answer, but those are just my thoughts, my train of thoughts on that. Yeah.
You were saying it's the kind of ControlNet, obviously the vocab changes, ControlNet is bolted onto, as you said, Diffusion 1.5 kind of base training data. So technically, in like this situation, you have your own training model you define. You use that in the set.
So the question is, I was referring to the whole architecture here of ControlNet being bolted onto Stable Diffusion 1.5. In the optimal case, you would have your own neural net that you use as a base. That's a very valid point, and that's the point that Chris and I have been rambling on and discussing forever and ever, because I think Stable Diffusion 1.5, which they are using here just because it was there when they wrote the paper, is for me a particularly bad starting point, because it's so biased on this ArtStation kitsch, let's put it that way. And I get why the people using ArtStation as their main platform, concept designers, are angry about this and shit scared as well, and rightfully so in a way. But even with Stable Diffusion 2.0 and 2.1, you could see this model being less biased in a way and being more, I'd say Stable Diffusion 2, 2.0, 2.1 feels more like geared towards photorealism, which might not necessarily be what you want. But there are methods of training your own neural network based on that, namely Dream Booth, which I haven't covered here. I think we've got tutorials on Entagma.com, also for free, like, comment, subscribe. But you could customize your own model. And actually, I think Chris didn't mention this beforehand, but most of the output that he showed, and it was on his Instagram, has been created using a model that he trained on his own work. So basically, your new oil, your new gold is your huge, in the best case, tagged data sets of your work. So if you have a huge library of your work with tags, I mean, this is an abstract representation of the world, of love, of water, and feed it 10,000 images. You can easily train your own neural net. And I think that's one way of going, and maybe one way of monetizing this for a designer. And I hate that I'm already at the point where I speak capitalist. Did that answer the question? Yeah? Question is say the last thing, please. So the question was, as this could be viewed as a very efficient compression model, can we expect something similar for other types of data, such as VDB, which are volumes, or simulation, for example? I think VDB is imminent, maybe not as VDB, but as NERF, which is a nice compression for that even. So we will definitely see in the medium to short time diffusion models that can generate volumetric models. If they are being used to generate simulation or simulation output, rather, is the same question or similar to the question if they can be used to generate video output or animation, which they already can-ish if you tweak them, but you have to abuse them. So I think there are networks trained on video so far, but the ones I've seen on the papers I've seen didn't look too convincing yet, but I think it's also going to come. So I could see simulation data coming as well. But don't take my word for granted on it. It's just a speculation on my side. Did that answer it? Okay, cool. Yeah? 2 questions, yeah? If I was able to include the prompts inside of the yeah, I was. I'll show you. And what's the second question? Sorry. Okay, so the second question was if there's a way to reverse engineer this type of network, to use it in the opposite way, to generate models from images. And I'm not sure if it's possible with Stable Diffusion. There are models out there that can do this already. Let's leave it at that. Quality-wise, so-so. And the other question was, did I input any prompts in here? Yes, I did, and I hid them. You can break them out into more accessible user dialable prompts, but that's my prompt. So highly detailed spaceship, style of Jim Berkey, extreme detail, UHD, 4K, Octane render, cinematic. And especially this shit down here. This is total dialect for Stable Diffusion 1.5. This already does not work in Stable Diffusion 2.0 to give me anything similar to this. So again, that's the downside of the semantics that you learn with the network that has definite biases in there. And also, you have negative prompts, which in this case are very general, and in Stable Diffusion 1.5 don't do much. If you use Stable Diffusion 2 or 2.1, they become important. Neg prompts is way more powerful than prompting in 2.0. So yeah, those are the prompts I fed in. Yeah? Am I using Houdini as a glorified compositor? Yes, I am. Yeah, absolutely. The point is, what I want to do here is augment my workflow with it. So basically, have this thing plugged in as a render engine. And this was just the cheapest way of me to feedback the output of this quote-unquote render engine in Houdini. Yeah. The use case, the true use case, or the more original use case for Houdini within the realm of deep learning would be to generate synthetic data sets. So you build yourself a chair generator, which outputs a bunch of different shapes of chairs in 3D. You render a few frames around it, generate the random next chair, render a few frames around it, yada, 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 and feed this into your machine to learn, okay, this is what a 3D model of this chair would look like if I take a photo. So exactly for the purpose of those networks that I mentioned, to answer the previous questions, you would generate this kind of data, typically in Houdini. And that's the original, the OG Houdini use in the AI context. But it's, I mean, debatable how creative that is. Yeah?
Just to understand how it's working,
Yeah.
can you get now also an interactive multi-render, or is it focused somewhere in the Latent space or the water?
Okay, I didn't acoustically understand you, sorry.
Just to understand, can you now get a noisy interactive render?
Oh, can I get a noisy interactive render and then have it clear up sequentially? Is that, yeah, I could. Yeah, I could. I was just too lazy. And actually that's what WebUI implements, where you can see this really coarse, really blurry image first, which then clears. Yeah? How much? How sustainable? By sustainable, so the question is, how sustainable is this workflow? You mean like in an ecological way? That's a good one. So I would look at it from two perspectives. I think deep learning and neural net-based image generation is going to be here to stay. So it'll last. On an ecological aspect, training the base models is quite a CO2 footprint. On a more artistic note, I think, already people won't pay you to prompt, or fewer people will pay you to prompt Stable Diffusion 1.5 to generate whatever cat image they want to use for their advertising in Munich airport. But again, I think the real value lies in modifying those data sets or training your own data sets on your style and maybe modifying the architecture of the network in a way that it generates unconventional output that can't be achieved with the standard bread and butter models that are out there and publicly shared. Is what possible? Oh, the question of accessibility with this. So yeah, I think you will see a further proliferation of that, and it will spread. Absolutely, everyone will be able to do this on their cell phones. Yeah, sure. Yeah. So the question about training data, well, how the training data should look like for that. Usually, you feed it images, and you have to correlate it with a condition that you want to train. So either from those images, if you want to train it on depth maps, you better have depth maps for the same images that you wanted to generate as output, and ideally have it tagged with something, some individual or unique identifier so that you can recall it. Did that answer it? Yeah. All right, cool. I'll be around here. I'll be introducing other speakers. We've got a 20-minute break, and then I think Paul is on. XK, sorry, XK Studios. So see you in 20 minutes for Alexa and Lucas. Thanks so much. Thank you.